Alright, here we have a source is approaching a wall at a speed of 70 meters per second, producing a sound of 500 Hz. Find the frequency of the reflected waves heard by the source. Okay, that's a good problem. So here we have a source, could be anything, could be a train or a car, which is approaching a wall, and the source is moving at a tremendous speed at 70 meters per second, and it's producing waves. It's gonna go hit this and it's gonna come back. And when it reflects back, the source will be able to hear his own sound wave. And the question now is, what's the frequency heard by the source? This actually is a two-stage problem. In the stage one, we can treat wall as the observer and the car as the source. So the source is approaching the wall and we can calculate what the frequency is going to be. But then, so let's call that as the apparent frequency f dash. But then in stage 2, the wall reflects this waves back. So wall acts like the source and the car becomes the observer. And the wall is reflecting waves at this frequency, but since the car, the observer now is approaching, it's gonna hear again. So there'll be 2 times Doppler effect happening. And it's f double prime, that's what we want to calculate. Alright, so let's do this. Let's do stage 1. In the stage 1, we're gonna treat the observer is at rest. So the stage 1 looks like this. Here is the source. It's moving at 70 and the observer is at rest. Alright, so what's the apparent frequency f prime? So that's going to be the original frequency f, and what's the original frequency? It's 500 Hz. So I forgot to put that. It's 500 Hz. Okay, I'm going to substitute numbers a little later. Multiplied by velocity of the sound v, and what's the velocity of the sound? Okay, it's not mentioned. Let's take the velocity of the sound to be 350. I remember. Meters per second. I should have mentioned that in the question. 350 meters per second. Okay, fine. So, anyways, it's going to be v. There is no observer, divided by v and vs. And it's approaching, so the frequency increases, and so the denominator should decrease. I put a minus sign. Right, now before we substitute numbers, let's just go to stage 2 and see what happens. In stage 2, the wall acts like the source and the observer is the one that's moving at 70 meters per second. I hope that makes sense to you. And the wall is now giving out waves of this frequency. You get that? Okay, so what's going to be the frequency heard by the source again? That's going to be f double prime. This is going to be the original frequency that is delivered by the source, which is the wall, multiplied by, now the observer is the one that's approaching, so that's going to increase the frequency, so the numerator should increase, divided by v, source is not known. Okay, if we substitute this over here, we can write f double prime as f prime, which is f times v divided by v minus vs, into v plus v naught divided by v. I hope you get that. I substituted this thing, so I took this thing and substituted over here. Okay, so that's what this is. So notice that v cancels and my answer turns out to be f times v plus v naught divided by v minus vs. Oh, this acts like as if the source and the observer both are moving towards each other at 70. So let's now substitute the values. We will get the original frequency, that's 500, multiplied by velocity of the sound, that's 350, plus velocity of the observer, well, the observer is moving at 70 in this case, divided by v, that is 350, minus velocity of the source, and the source is also moving at 70. So that's going to be 500 times 350 plus 70. Notice 70 goes 5 times. So 70, I'm just gonna write this as 70 times 6. And this is 70 times 4. I hope you understood that. 7 goes 5 times, so this is 70 times 5. Plus 70 gives 70 times 6. 70 times 5 minus 70 gives 70 times 4. So 70 cancels. So I get 500 into 3 by 2. That's going to be 250. That's 750 Hertz. I hope I did not make a slip. Yes. So the apparent frequency heard by the source reflected waves is 750 Hertz. Okay, so that's our answer. I'll see you in the next episode. Stay tuned.